Here we have a clear liquid and a clear solid. The liquid acts like a liquid. It takes the form of the jar, it flows. The solid acts like a solid. It has a specific shape. You're going to write a hypothesis. What do you think is going to happen when I add the solid to the liquid? How will they interact together? What is your hypothesis? Go ahead and pause your video and write down your hypothesis. Now we're going to add the solid ice, to the liquid, and you're going to see if your hypothesis was correct. Was your hypothesis correct? I want you to make some observations. One observation I want you to make is how far down did the ice go? Did it float at the top? Did it go to the bottom? Is it hovering in the middle? The ice in this case, it looks like, starts right at that bottom of the ruler, that 0 millimeter line. And we're going to watch this for a couple minutes, and as we watch this, make a couple more observations. Your first observation should obviously be that the ice sunk to the bottom of the clear liquid. What other observations can you make? In order to help us see if we can distinguish what's going on with the glass and the liquid, I'm going to put this beaker halfway in front of a colored paper and halfway on a black background so you can kind of see the difference. And maybe that can help you see what's going on as we watch this for the next couple of minutes. Make sure you're making some observations now. Look at the ice layer. Is the ice going as far down in the beaker as it was before? You can see with the colored background, you can see it a little bit more clearly. But there's an ice layer now kind of in the middle. There's still our clear liquid at the top, but it looks to me like another clear liquid, as this ice melts, is forming at the bottom. So we've got 3 layers. 1, 2, 3. It looks to me like the liquid layer at the bottom starts about right where the ruler is showing the 1 millimeter mark, or the 1 centimeter mark. And then that layer of ice in the middle is about a 1/2 centimeter wide. And then starting at the 2 centimeters up until the 3.5 is our original clear liquid layer. You can see that, and if you look on the black side, you can even see that this layer has a different texture, a different clearness than this layer. So even though this bottom layer is liquid now, as the ice melts, it looks like it's a different liquid from that clear liquid. This one is a lot clearer than that one. So there's some observations. We have measured out 75 milliliters of the clear liquid, and we have zeroed out our scale. So now we're going to measure the mass of our clear liquid. And the mass of it is 65 grams. We're now going to take measurements for the solid, that solid ice. We'll start with mass. We'll put it on a scale. And we've got 14 14 grams for that ice. Now it's a little bit hard to measure the volume of such an irregularly shaped substance, so we're going to use the water displacement method, where we start with a known volume of water. We have 60 milliliters of water in here, and when we add the ice, it takes it up to 65, 70, 75, right about 75. But because we started with 60, only 15 of that is our solid ice. So that means the volume of our ice is 15. Here we have the melted solid. So this is not the same clear liquid that we started with. This is the solid that has then melted and that formed our third layer. So this was our bottom layer. Here I've measured out 75 milliliters. You can see that this is in milliliters. I've measured out 75 milliliters of this clear liquid. And we are going to weigh that on our scale to get the mass. And it says we are at 74 grams.